right, one more example of a simple problem using the quadratic formula. Only this time we're going to look at what happens when we end up with solutions which are radicals and not simple rational functions or simple integers. So let's write our quadratic formula up here. We have, remember our little song that we worked on. Our quadratic formula is, and sing along, x equals opposite b plus or minus square root b squared minus 4ac divided by 2a. Sure, you can make fun of the way I sing. That's fine. But memorize the quadratic formula. So the first problem that we're going to work with is 2x squared minus 1 equals 5x. And the problem with this is it's not in standard form. So the very first thing that we have to do is move that 5x to the other side, put it where it belongs, and we end up with a quadratic in standard form that says 2x squared minus 5x minus 1 is equal to 0. We want to plug this into the quadratic formula, so probably you want to go through and you want to figure out what a, b, and c are. So in this case, a is equal to 2, b is equal to negative 5, and c is equal to negative 1. Once we have determined what a, b, and c are, then we are going to substitute those values into the quadratic formula. So, x is equal to, we're going to put a, b, and c in where they belong, and the first thing we have is opposite b, so we have a minus 5 that goes in for our b term, plus or minus the square root of, and b squared, negative 5 in parentheses squared, minus 4ac, so minus 4 times 2 times negative 1. All of that is over 2a, so 2 times the coefficient of x squared would be 2 times 2. Now our terms at this point become negative and negative, so opposite of 5 is going to be, opposite of negative 5 is going to be positive 5, so we have a 5 plus or minus, because we have two possible terms, the square root of, and then we start simplifying. Our negative 5 squared is going to be 25, and then when we multiply together negative 4 times 2 times negative 1, we get plus 8. That gives us 5 plus or minus the square root of 25 plus 8 over, and we multiply 2 times 2, and when we multiply 2 times 2, we get the quantity 4. So when we come back and we want to simplify this into one more step, and we said this time we weren't going to get a nice, neat integer or rational solution, because this time we've still got something out of the radical that won't simplify. And that doesn't always happen. If it won't simplify, then we need to leave it as a radical. So we're going to have 5 plus or minus, and underneath that radical is the quantity square root of 33, and all of that is over 4. This can be written as two separate fractions. We don't do that all the time, but be aware of that. It can be written as 5 over 4 plus or minus the square root of 33 over 4, and write that as two separate fractions. It doesn't really matter which way you choose to do that. In fact, you can write it as two completely separate zeros of the function and say 5 over 4 plus the square root of 33 over 4 and 5 over 4 minus the square root of 33 over 4 when we talk about both zeros that we found with the quadratic formula. Another tool in our tool belt for solving a quadratic is the quadratic formula.